72%. That is how often researchers hijacked an AI agent using a tool's help text. Not a prompt, not a jailbreak, the documentation. Your client pulls that tool list before you type a word. Whoever wrote that list is writing instructions for your model. You installed them, one click. You never saw the code. Anthropic counted 10,000 public servers, 97 million downloads a month. Let's look inside the pipes. 2 years ago, your AI could write a script. It could not run it. Now it runs it. Reads your files, opens your database, sends the email. The thing that made that possible is a protocol. Anthropic shipped it, then gave it away. OpenAI shipped support. Google, Microsoft, AutoMS, your editor. A standard is a good thing. It is also a single shape for every attacker to learn once. Here is the part the diagrams skip. Connecting a tool is not a network call. It is a command. That field is handed to your operating system. The protocol's job is to launch the process. That is the design. So there are 2 doors into an agent, not one. Door 1 is the config. Whatever lands in that command field runs before the SDK checks whether it's even an MCP server. No model involved, no prompt involved. This is plumbing. Door 2 is stranger. The tool's description is not documentation, it is part of the prompt. Researchers put hidden instructions in that field. Read this file, send it here. Do not mention this. The user sees a calculator. The model sees a job. The poison tool never got called. Loading it was enough. Microsoft published the same warning in June. Their example was invoices. So, one door needs no model, the other needs no prompt. Neither needs you to visit a bad website. Here is the whole attack, start to finish. It takes 6 steps and none of them look wrong. 1. You install a server from a directory. It has stars and a nice README. 2. Its tool list loads into context. You have not typed anything yet. 3. Inside one description, an instruction the interface never renders. 4. You ask for something boring. Summarize my week. 5. The model picks a tool. It is following instructions, just not only yours. 6. The tool runs with your permissions. Because it is your agent, 20 agents were benchmarked against this. The best refusal rate was under 3%. In that benchmark, the better the model, the worse it did. Instruction following is the vulnerability. 1 tool is a problem. 5 tools are a different problem. Each one is harmless alone. Combined, they give an agent 3 things at once: private data, untrusted text, and a way out. Simon Lillison named it the lethal trifecta. Any agent with all 3 can be turned around. It is not theoretical. A public GitHub issue was used to make an agent read a private repo and publish what it found. The server was not broken. Every tool did exactly its job. The chain was the exploit, which is why there is no patch note for this one. Nothing was bugged.
How could this happen?
None of this stayed in a lab. September 25. An NPM package impersonating a real email server. 15 clean versions. The 16th added 1 line. The line was a BCC. Every email sent through it was copied to the attacker. February this year. Attackers cloned a fitness tracker server, built fake contributors around it, and shipped an info stealer. Researchers say it targeted developers. Because developer machines hold cloud keys, tokens, and production access, Cursor had a subtler one. Approve a tool config once, and swapping it later did not ask again. And in April, scanners found 12,000 MCP services exposed on the open internet. A week later, 21,000, 687 exposed command execution. 1,000 more, database queries. An MCP doesn't require authentication by default. Those 4 have patches. The interesting part is the one that won't. In April, researchers reported that config to shell execution to Anthropic. Anthropic's answer, that is expected behavior. Expected is not the same as safe. Their position, the developer sanitizes the command, which is defensible. A transport whose job is launching a local process has to launch a local process. The spec even lists the attack, sandbox it, show the command, get consent. Those are the words must and should. So the spec is not naive, the ecosystem is. 9 published CVEs landed on products that piped user input into that field. The spec says should. The registry says install. Guess which one shipped? None of this is new. Prompt injection is years old. What changed is where untrusted text enters, what the tools can reach, and how many are connected at once. The fixes are known. Sandbox the server, scope the token to one repo. Approve the command, not the vendor. OWASP now ranks this. Tool use, supply chain, and code execution are 3 of its top 10 agent risks. But the last one hands the decision back to you. A dialog box asking if you are sure. The protocol did exactly what it promised. It turned text into actions. We just assumed we would be writing the text. Check what you installed.